convert from decimal form to scientific notation. First, I want to say that decimal form is sometimes called standard form. I use those interchangeably. Just know that standard form or decimal form, those are the types of numbers that we see on a regular basis, right? Those are like the general way people write numbers. Scientific notation is a way for us to write big, or really small numbers. So the way we do that is we have a number, and this number is going to be greater than or equal to 1, but less than 10. Okay, so it has to be between 1 and 10 is how you'll hear a lot of people talk about that, right? And then we're going to take that number and we're going to multiply by 10 to some power. Now, this exponent is going to be positive if our standard form number is greater than 10. And it will be negative if our standard form number is less than 1. So my brain works really well thinking about money. So if you said, Becky, I'm going to give you $100. That's greater than 10. In my mind, that's positive. Anybody can give me $100 and I'll be happy. So that's positive. If people say, hey, I'm going to give you a penny. What am I going to do with a penny? Like I need like a gajillion people to give me a penny to make that worth anything, right? So it's less than 1, that's negative because that's not paying any mortgages, right? So that's kind of how I remember this. So let's write in scientific notation. Okay, so I'm looking at letter A. I have 47,500. This is a big number, right? If somebody just dropped this amount of money in your lap, you'd be like, yeah, I'm going to buy me some shoes. This is positive. So I know when I write this in scientific notation, I'm going to have a positive exponent. Now, our first order of business is to get that first number. And that first number needs to be between 1 and 10. So I say, okay, if I put the decimal point right after the 4 and include all non-zero numbers, so 4.75, I have successfully got a number between 1 and 10. Okay, so times 10 raised to the what power? How do I know the exponent? Okay, well, in this number, if you don't see a decimal, it's at the end, right? So we know that the decimal's at the end, and my arrow is between the 4 and the 7. That's where I'm moving the decimal to. So if I started my decimal here and say, okay, 1, 2, 3, 4. That means my decimal moved 4 places. I know it's positive because that's a big number, and therefore 4.75 times 10 to the 4th is scientific notation. Let's go to letter B. Okay, this is a small number, 0.000783. It is way less than 1, so my exponent is going to be negative. Just keep that in mind. These are like the little common sense things that you just can't forget. So where am I going to move my decimal? Well, I need that first number to be between 1 and 10. So 7.83. Well, 1, 2, 3, 4. So times 10 to the negative 4th. So you always start with where the decimal starts and then you move it. I always exaggerate the movement because that helps me count. So I end up with 7.83 times 10 to the negative 4th. We know it's negative over here because of how small this number is. Let's do 2 more. 0.07. That is less than 1. That is small. That means my exponent is going to be negative. So where do I need to move my decimal point? After the 7. So I'm just going to have 7. That's the only non-zero number. Times 10 to what power? Well, if my decimal point starts here, I'm going to move it 1, 2 places, so that'll be a negative 2. This is also why sometimes I'll write like pos, right? Just to remind myself about my exponent. In letter D, 4,050,000. Okay, well, that's really big. So this is going to be a positive exponent. So I want my decimal point to be after the first non-zero number. So I'm going to have 4.05. I've got to have all non-zero numbers as part of this. Times 10 to what power? Well, I don't see the decimal point, so it starts at the end. It's okay, so let's count. 1, 2, 3, 4, 5, 6. That's a positive 6. And that is writing in scientific notation.